Let me feel it, you guys. So class.
Yes.
Thank you. Here, good. You get candy. Good boy. Anyway. All right. So using implicit differentiation for the equation of the tangent line. Find the equation of the tangent line to the graph of the ellipse. I know you guys love ellipses. 3x squared plus 4y squared equals 2x at the point 1 half negative 1/4. Graph the equation of the tangent line on the same set of coordinate axes. All right, so let's go through. So I'm going to rewrite. And so 3x squared plus 4y squared equals 2x. Now let's go ahead and do the implicit differentiation. So we're taking the derivative according to what? X. Right? We're taking the derivative according to x. So when I'm taking the derivative of something that's not x, I have to tell it, be like, hey, yo, these are the derivatives according to x. So let's go ahead. What's the derivative of 3x squared? Very good. Plus, what's the derivative of 4y squared? 8y? Is that it? Is it? Is it? Yep. ddx. Or dy dx. Okay, so we're taking the derivative of something that's not x. I have to state that I'm taking the derivative of something that's not x. Equals. What's the derivative of 2x? Now, to go ahead and find the slope of this, or find the full derivative, what do I have to do? I have to do a little bit of algebra here, right? So I need to get what by itself? Get dy dx by itself. Subtract 6x. Eight y dy dx equals 2 minus 6x. But wait, there's more. What do you got to do next?
Divided by 8y.
Excellent. 8y. So I'm going to bring this up over here now. So as I do that, I'm now going to have dy dx is equal to 2, that's a 2, minus 6x over 8y.
Can we leave it as that?
Yep. Yeah, that's fine. Because I'm just asking for the derivative, right? I'm not saying the derivative in terms of x or in terms of y, where you would just get it into y only or something like that, or x only. Right now, this is fine. This is an implicit differentiation, and I'm happy with it. What's one thing I could do to make it a little bit? Because if this is a multiple choice answer, what would my answer be that's on my paper? Is there anything I could do with this thing?
Oh, make it turn it into
How about start to the R, ends in deuce? By what factor? By 2. Reduce by a factor of 2, can I? So yeah, so if you're looking at a multiple choice answer, factor 2, so it'd be 1 minus 3x over 4y. So all the times when you're looking at answers and there is a multiple choice answer, you need to think about what is going to be equivalent answer, because you have to match your answer with what they have. Okay? On all the multiple choice, that not saying that your answer is going to be wrong, it's going to be equivalent, but now you have to figure out which one's it going to be, because sometimes they do something weird. There was one AP exam, they multiplied but like everything by the quantity of like x plus 1 or something, which actually made it bigger. Like no one ever does that. So anyway, so there it is. But there's more now. What's it say now? Find the what? Tangent line, the tangent line. So I am going to find the tangent line at 1/2 negative 1/4. Do I have more room here? No. So I have and that was, what do you say, 1 minus 3, 3x, right? Over 4y. Like that. So I'm evaluating. So this is the notation that we had used, kind of like, you know, how you'd say like f of 1/2, or other way of doing it. This is kind of the Leibniz notation for that. Alright, a little bit of math here. So that's going to be 1 minus 3 over 2 minus 1. 1 right there, and this is actually, turn that into 2 over 2. So that's going to be negative 1 over 2 divided by negative 1, which is just that's me canceling out the 1. So I don't know if you guys look like an X too much for me. Does that make sense? Nonsense? A little bit of sense. Absolutely no sense at all. I could toss a dice and get 6s every time, and that would make more sense than this. We good? Okay. Alright, so now what does this actually represent? A slope at the point. So slope at the point, so it's going to be m is 1/2. So I have an m, and what else do I have? Do I have 2 points? Okay, let's do that. So since I have m and the points, it's going to be y minus negative 1 over 4 equals 1/2 times quantity of x minus 1/2. So y plus 1/4 equals 1/2 x minus 1/4. Subtract 1/4 from both sides, so y equals 1/2. That should be a 1/2. There we go. All right. X, and so since I'm subtracting, that's negative 2/4. There you go. Because it's minus 1/4 here, minus 1/4 here, which is 2/4, which reduces to 1/2. So there should be the equation of my tangent line. Now this next part here is going to be key, because I'm pretty sure you guys don't really know how to actually graph these type of equations yet. Or do you? You guys know how to graph these type of equations? No? Maybe? Alright, I'm going to pull up my ready? Now, do you guys know how to plug in these equations without turning it into y equals? go. So, there, got my mouse back. I'm going here. Now, this input line right here says what? What does it say? F of x, and what does f represent? A y. What else does it represent? A function. Okay. Now, it's not a function right here because I can't have x and y in a function. So what I need to have, because I'm going to have an x and y in my problem, I need to have a relation. So backspace here, and it'll give you the option to the different types of functions you could enter. And we want option 6, a relation, which is my x and y. And what was the problem in the first place? So like 3x?
3x squared
Okay, so 3x
squared
plus 4y
squared
squared
equals
equals 2x. There we go. So as a relation, I could now do this, because we said this is an ellipse, right? And can we normally graph ellipses? Okay, he's shaking his head. Why can't I graph an ellipse? Neff, why can't I graph an ellipse? Is it a function? What rule does it break? Vertical line test. There we go. Vertical line test. So it's going to break the vertical line test. So menu. Let's go zoom. There we go. So there's my ellipse. Because it will break the vertical line test, it's not a function, and my calculator doesn't like to graph it. But it will graph an ellipse. So I need to go tab, and now I am going to do what's my equation? So it's y equals 1/2, right? X minus 1/2. There we go. Now, from our definition of a tangent line, what does a tangent line do? It touches at one point, especially when we're talking about an ellipse, a circle. It touches only on one point on the curve, and so that's what that does right there. And I could even plot the point, which my point here should be menu, analyze, intersection, right here, right there. So as a decimal, there it is, my positive 0.5 and my negative 0.25. So how do you guys feel about those? Not so bad? Okay, so how do I get to relation again? Do what? I almost heard it. Say it again. How do I get to a relation? Backspace, right? Just delete it, and then you will actually get there. All right, there we go. Let's go back to our problem. There we go. Graph them here, same set. find y prime, so the derivative of y given e to the y, cosine x equals x plus 1. Alright, now I gotta turn my thing back on and hopefully it will continue working. Alright, so let's go ahead and find the derivative here. So if it is e to the y times cosine x equals x plus 1. What rule is that using? Yeah, it's product rule. So it's going to use product, so I'm going to make sure I'm actually doing that. So f and g, so f is e to the y, f prime is almost dy dx, right? G is cosine x, g prime is negative sine x. There we go. So now I'm going to put that all together. So my product rule. Oh, thank you. All right. So f prime g, so that is going to be e y dy dx times g, which is cosine x, plus g prime, which is negative sine x. So there's g prime and then f, which is e to the y, equals, the right side of this is going to equal what? Just the right side. We're still over here. Because we have to get just one, right? Okay. So on all these implicit, you'll notice that there's an equal sign in there that it's going to be equal to, that I can actually manipulate on all those. Okay. So now, if I was looking at all of this, I would just say, man, looks like kind of a mess. So we're trying to get what by itself? Very good, dy dx. This left side looks like a mess. But if I know that all I need to do is get dy dx by itself, this is just algebra. They're just ugly algebra, but it's algebra. So I'm going to, since right here, this is going to make this become a negative. I'm going to subtract it to the other side, or add it to the other side, sorry. So on the other side, it's going to be a positive e to the y sine x. Because these two right here make this negative, so I add it to both sides. So e y dy dx times cosine of x is equal to 1. And right here, I'm going to add it to this side, plus e y sine of x. And what do I need to get? So my e to the y and the cosine x is doing what to my dy dx? Yeah, it's multiplying. So yeah, like I said, this is just algebra, so it's just ugly algebra. So if it's multiplication, to undo the multiplication, I need to divide both sides. So I'm going to do that. So I'm going to end up with dy dx is equal to 1 plus e to the y sine of x divided by e to the y cosine Are you okay with that? Not too crazy? Alright, so from there, it says find the equation of the tangent line to the graph at the point. So dy dx at the point 0, 0 is going to be 1 plus e to the 0 times sine at 0 divided by e to the 0 times cosine at 0. So thinking of that unit circle, at 0, cosine is what? It's 1, right? Cosine at 0 is 1, sine at 0 is? Did you guys forget to get the unit circle tattooed again? What's sine at 0? Cosine. Cosine is 1. So if you think about this circle, we're talking about this point right here. So it's on the x-axis, so that's 1 that way. It's not up and down at all, so that's 0 there. So 0 times e to the 0 is 0, so this is going to give me 1 on top. Cosine at 0 is 1. E to the 0 is 1, right? So that's going to be 1. So the slope of the line at the point 0, 0 is 1. But wait, there's more. What do I have to find? Equation of the tangent line, not just slope. So I'm going to say y minus 0 equals 1 times the quantity of x minus 0. So my equation is y equals x. And this is my tangent line. Mic drop. Okay, good. Have you had enough? Have I tortured enough today? How many more do I have?
6 maybe?
Do you have a bunch?
5 more.
Okay, it's fine. So these are actually the doubles, and so this is actually going to be its own headache. So I'll pick these up tomorrow. So getting your second derivative. So make sure you guys all like, share, and subscribe.